Today's lesson is the first lesson on probability for grade 12, and we're first going to look at what the fundamental counting principle is. Now let's say, for instance, you have a coin and you have a dice. If you roll the dice, how many possible ways can it land on? 6. If you roll, or if you toss the coin, how many possible ones? 2. Now if I combine both of them, how many combinations can you get? 6 times 2. 6 times 2. And that is the fundamental counting principle. So the total number of combinations of the first event's total number of outcomes times the second event's total number of outcomes, and then if you multiply them, you get the total number of combinations. Let's look at an example. Jack and Jill visit a restaurant and they have a menu with 4 starters, 3 main meals and 3 desserts. Now I always write down how many of everything there is. 4 starters, 3 mains, 3 desserts. Now they ask, Jill only wants a starter and dessert. So she only wants 4 possible starters and 3 possible desserts. How many combinations can she order? 4 times 3, and that equals 12 combinations.
So in this question, there's no thing like a formula. Just going to.
Yeah. Yes. Then number B. Jack wants to order from all 3 courses. From how many different combinations can he order? So he wants the starter, the main and the dessert. So you multiply all 3 of them and you get 36 different combinations. You all follow. It's very, very easy. Example 2. Okay, now we have to think a little bit. A password can consist of numbers and letters. And it must be in the format XXX, YYX, where X is a letter and Y is a number. Now you quickly need to think, how many letters in the alphabet do we have? 26. And how many numbers in the number system do we have? Digits? 10. 0 till 9. It's 10 numbers. Alright. So if we write the formula of the password, now we have to substitute how many of them we can choose. How many different passwords can you make in this format if you have 26 letters and 10 numbers? Right, in the first letter position, you can choose from 26. In the second letter position, you can also choose from 26. Third one, 26, and now we get to the numbers, the digits. The first digit can be 10. The next digit you can also choose from 10. And then the last number in the password you can choose from 26 letters. Do you all follow? So these are the choices that you can make. How many combinations can you make from those choices? You multiply everything. 26 times 26 times 26 times 10 times 10 times 26, and that will give you 45 million plus. Now, aren't you glad that we have this principle? Because otherwise you would have had to draw a tree diagram. So I'm very glad about this principle. Let's look at the next question. How many different passwords can you make if you exclude the vowels, how many vowels are there? 5. So if we exclude them, it's 26 minus the 5, so we're only left with 21 possibles. And if you substitute it into your format, you'll get 21, 21, 21, 10, 10, 21, and if you multiply them out, it's more than 19 million. You all follow? Okay, very easy. Yep.
Like you see on this topic that I'm referring to, like things that supposed to be general knowledge. Like what else is supposed to be general knowledge? You just tell us.
General knowledge. You should also know the pack of cards by heart. A dice, a coin, and if they talk about placing children on chairs, okay, we'll get to that, just hang on. Let's quickly complete this question. Now, how many different passwords are possible if no numbers nor letters may be repeated? So, you write your format. Always do the format. Do your planning. How many letters do we have? 26. We can't repeat, so we place one. How many letters can you choose from for the second one? Yeah. And for the third one? 4. Okay, let's skip the numbers and then 23. Now look at the digits. How many can you choose for the first digit? 10. How many can you choose for the next one? 9. And how many possibilities are there? You multiply everything. Alright, now. How many different passwords are possible if the numbers must be the same? Okay, this is a question that you always get somewhere. Numbers must be the same, or letters must be the same, or the boys want to sit together, or the girls want to sit together, or whatever. So if you have a group of the same thing, you consider that as a unit in order to count your possible ways. Okay. So, we may repeat, so we have 26, 26, 26, but you treat the numbers that need to be the same as a unit, so there's only 10, and then the last one is 26. Do you all follow this? And then for the possible number of passwords, more than 4 million. How many passwords can you make if the password needs to start with a B and end with a K and you can't repeat? Okay, so you put your B and you put your K. Now we have 26 minus the B minus the K. How many is left? 24. We can't repeat, so this is 23. And then we start with the numbers, 10 and 9. Then you multiply. This is 1 times 24, 23, 10, 9, and 1. And you get your answer. Any questions? Do you agree it's sort of easy? You just need to think what they ask. Okay. Your homework exercise 2, number 1 till 4. And now I want to mark the homework.